All right, kids, there's not going to be a whole lot in this particular video, just because when I post the solution sheet, they don't really have most of what you need. This is an opening proof. There's nothing that you need me for, I don't think. I will tell you that it ends up being 8 steps. That's what I had. Notice that you do have a double here. So I'm thinking, hey, there might be an possibility of using multiplication or division. Keep that in mind. All right, you can check the solutions later. So in the beginning of the year, we talked about altitude medians and perpendicular bisectors. Bisectors, we've been using this regularly, the bisectors. If a segment bisects a segment, then it divides into two congruent segments. We've been using that for a while. Same thing with angles. We haven't talked about altitudes and medians in a little bit. We talked about that at the beginning of the year. Altitudes, remember, come from a vertex, and they're drawn perpendicular to the other side. Okay. And then medians also come from a vertex of a triangle, and they are drawn to the opposite side's midpoint. So we did some problems when we were doing equations of lines back in the first unit, but we haven't used these two things yet with proofs. Now, instead of rewriting it again, I will tell you that the altitude, that information for the reasons is gold number 25, and medians is gold number 24. Bisectors we've been using for quite a while, so that's nothing new. I'm not going to write out these things, but you want to pull out your reason sheet and take a look at that. Notice how when it says altitudes, like 25A, it says an altitude of a triangle forms right angles with the side to which it's drawn. So that's the reason we're going to use, which is usually handy. In other words, it's saying it forms right angles rather than perpendicularity. Usually we want the right angle anyway, so that's nice. And notice how a median says it divides a segment in 24A. It says it divides a segment to which it's drawn into two congruent segments. So that is handy as well. Now there's also B versions, so just make sure you're comfortable with that on the gold sheet. So we've gotten pretty far down on the gold sheet. Okay, auxiliary lines. Sometimes you will need to draw in lines in your diagram in order to solve the proof. Okay. That's also listed on your gold sheet number 26. This is a reason. Okay. 2 points determine a line. In other words, how many lines can I, watch this, how many lines can I draw through 1 point? I could draw an infinite number of lines through 1 point. It takes forever. Okay. But if we had 2 points, how many different lines can we draw through those 2 points? Just one, or one segment. And that's going to be very handy. So let's take a look here. So AM is congruent to AH, MT is congruent to HT. You have to prove that AT, and this is awfully leading, right? It actually mentions AT. So let's go ahead and draw that in, and you actually have a step. Draw AT, and that reason is 2 points determine a line. Now I know we're writing line, we just drew in a segment, but still 2 points determine a line that determine a segment. In that regard, it's the same thing. So now you've probably recognized, hey, I got some reflexive action there. So I can now prove triangle. Remember, make sure you match them up correctly. Triangle ATM to triangle ATH. And that would be SSS. Now, we're not done yet. Now you have to say the angle MAT is congruent to angle HAT. Now, that's by CPCTC. And we're still not done. Notice how we have to prove what? We have to prove bisection. So we actually have to say that AT bisects angle, and I'm not even going to call it angle A anymore because there's multiple angles there. I'm going to call it angle MAH. Now this is the B version of the bisecting reason, okay? So make sure you use the correct one. If a segment divides an angle into two congruent angles, then it bisects the angle. A lot of times students will give the converse, they'll give the A version of the reason, so be careful with that. Okay? Okay, big word of caution here. Don't get carried away with auxiliary lines. In other words, just because you're able to draw auxiliary lines doesn't mean that you're going to be drawing them willy-nilly all the time. Yes, you can draw them in, but again, it's not. I mean, most problems you're not going to draw them in, and I will tell you the most common type of problem that you draw in lines is often with circles. You have to ask yourself when you see a circle, what does drawing in a radius help me on this problem, for example? Okay, so that's what you want to keep in mind. All right, so here's a proof. I'm going to walk through this one. GE is perpendicular to AD. Wait a second, yeah. And just making my right angle symbols here. AD is an altitude. It says AE is congruent to BD. It says angle ABC, this big angle, is congruent to angle BAC. So there's a lot of stuff going on here. Oh, and then I got a double bisection. I'm not going to mark that. I got a double bisection, so this is a bisector, as is that. So this is one where you have to think a little bit. Maybe, look ahead at the proof. You have to prove AG is congruent to BE. So I'm thinking, AG, it's in this little triangle right here. BE is in this little triangle right here. Maybe I can prove those two triangles congruent, those two little ones. They both have right angles, so that's a start. Hey, wait, we got this big angle congruent to this big. You know what? We can do this because it's going to take a lot of steps, but it's not a big deal. Just look ahead to see what you have to prove. So it looks like I'm going to want to have this little angle congruent to this little angle. So I'm going to take care of that first. That's like divisions, right? We were told that these holes are congruent and both have been bisected. So angle GAE is congruent to angle EBD. If angle's congruent, then like divisions congruent. And now I got to establish this right angle here and here. But notice how it's two different reasons. So we can't put these in the same step. Angle GEA is a right angle, and that's if lines perpendicular then intersect at right angles. And then down on the bottom, this is due to the altitude reason. So angle BDE is a right angle if segment, remember this is the new reason now, number 25A, if segment is an altitude, then forms right angles with side to which drawn. Sorry, a little bit messy there. Okay. If segment's an altitude, then forms right angles with side to which drawn. So now we can finally say angle GEA is congruent to angle BDE if angles right angles then congruent. So it took us all those steps just to take care of the angles. That was That took a little bit. But now I think we're ready to say we have congruent triangles, right? So we have, come on, there we go. We have triangle AGE congruent to triangle. Be careful, I'm matching this up. If I say AGE, I got to say BED, and that's by ASA. And it's just a 7-stepper, but it's a little bit tough. AG congruent to BE, CP, CTC. This next proof I'm not going to do. I'm going to post the solutions later, of course. But there's nothing new here. This is just stuff that we've done before. You guys are totally capable of doing this. There's no double here. There's no multiplication or division. It's just a bunch of ideas that we've done before. I actually had 9 steps, so it's pretty lengthy, but totally doable. See what you can do. And then this last one, you know what? I'm not too sure who created this proof, but I realized this proof is kind of messed up. You can do this. You don't need all this information. Watch this. If JH is congruent to FG, okay, we actually don't need this. It says that angle, we don't need this one either. We have angle KJG, this angle here, congruent to MGJ. And then we also have JGH, that's this angle, congruent to FJG. And I think whoever, let's look ahead. We have to prove JF congruent to HG. And I think whoever set this up was probably focused on these outer triangles, JFM and GHK. But with this given information, we can actually get this triangle here, triangle JFG. Actually, you know what? We don't even need these blue angles. This really is amazing. We don't need this either. Watch this. See, we can say that JG is congruent to JG. And that's reflexive. And then step 3, we have congruent triangles, don't we? We can say that triangle JGF is congruent to triangle GJH, and that's due to side angle side. And it looks like we can just do this in 4 steps and get rid of a ton of the givens. So that would be CPCTC. So actually, I realize, yeah, I don't think it can be done any quicker than that. So that problem was a little bit messed up. Sorry about that. Happens sometimes.